in a groundbreaking revelation that could redefine our understanding of humanity's place in the universe. NASA has reported the detection of what appears to be the first extraterrestrial signals originating from the direction of Proxima b. This planet, situated just over 4 light-years away, lies within the habitable zone of its parent star, Proxima Centauri. The discovery has sparked global excitement and widespread curiosity, as people around the world consider the possibility that we may not be alone in the cosmos. For years, astronomers have closely observed Proxima b due to its Earth-like features and proximity to our solar system, making it a prime candidate in the search for alien life. The signal that has been detected is not just another random burst of cosmic noise. It stands out as something truly unique, unlike anything ever observed before. This has led experts to believe it could mark a turning point in the history of human civilization. The journey to this potential discovery began with extensive monitoring using NASA's high-powered telescopes, which continuously scan the skies for any signs that might hint at life beyond Earth. Proxima b has consistently attracted scientific interest, as its characteristics suggest it could support life under conditions similar to those on Earth. The nature of the signal detected is highly structured, exhibiting patterns and repetitions that suggest it may not be a product of natural cosmic activity, but rather of intelligent origin. As a result, teams of NASA scientists along with international researchers are now working intensively to analyze the data and decode the message, if it is indeed a message. They aim to understand what it might be saying and what its purpose could be. This has ignited a flurry of theories and speculation across the global scientific community. Could the signal be a form of communication, a greeting, a warning, or something entirely beyond our comprehension? The news has spread far beyond academic circles. It's become a hot topic on social media, in political discussions, and even at family dinners. People everywhere are once again gazing at the stars, wondering if beings on another world are doing the same. What might their lives be like? Could their civilization be more advanced than ours? Or are they just beginning their journey through the cosmos? This scenario opens up profound philosophical, ethical, and existential questions. If we are indeed receiving a message from an intelligent alien source, how should humanity respond? What guidelines should we follow in establishing communication? And how would such contact affect our views on life, religion, and our place in the universe? Although enthusiasm is mounting, scientists are also proceeding with caution. There is a palpable sense of responsibility among researchers to ensure that what they've found is genuine. The signal must be thoroughly verified to rule out any errors or false positives. Experts are carefully examining every possibility to ensure that the phenomenon is not simply a product of Earth-based interference or an error in data collection. This level of diligence is necessary because the implications of a confirmed extraterrestrial signal would be enormous. As we await further analysis, the world finds itself on the edge of a potentially historic moment, one that could unite humanity in a shared quest for understanding and connection beyond our planet. The signal in question was initially detected in April 2019, originating from the Proxima Centauri region, located 437 light-years away. While that may sound distant, it is the closest star to our Sun, being about 3 times farther than the third brightest stars visible in our sky. Proxima Centauri is part of a triple star system that includes Alpha Centauri A and B, which are quite similar to our Sun. Alpha Centauri A shines brightly with a yellow hue and is 1.5 times more luminous than the Sun, whereas Alpha Centauri B emits a softer orange glow and is half as bright. In terms of size, Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is slightly smaller, placing our Sun right in between them in terms of scale. But where exactly did this mysterious signal come from? The detection was made by the Breakthrough Listen project, a scientific initiative dedicated to searching for extraterrestrial communication throughout the universe. Funded with around $100 million, the project uses thousands of hours of observation from state-of-the-art telescopes worldwide. The particular signal, dubbed Breakthrough Listen Candidate 1 or BLC-1, was picked up by the Parkes Radio Telescope in New South Wales, Australia. It was found while the telescope was scanning the area around Proxima Centauri. Amid a mountain of collected data, this signal stood out like a needle in a haystack. To qualify as significant, a signal must have two key traits. It should be limited to a narrow frequency band, something not typically created by natural cosmic events, and its frequency should vary in relation to the movement of the exoplanet relative to Earth. Scientists combed through nearly 4 million individual signals captured by the telescope, gradually narrowing them down to 5,000 relevant ones. Among these, one remained unexplained even after cross-referencing with all known Earth-based radio transmissions. This particular signal only appeared when the telescope was pointed toward Proxima Centauri and was observed over a period of 30 hours. After detailed analysis, researchers traced the signal's origin to Proxima b, a planet discovered in 2016 using the radial velocity method. This technique tracks slight movements in a star's position caused by the gravitational pull of orbiting planets. When a star wobbles slightly and repeatedly over time, it's considered strong evidence of an orbiting planet. Proxima b has several Earth-like features. Its radius is about 1.1 times that of Earth, and its mass is approximately 1.3 times greater, suggesting it's a rocky planet with a similar density. However, there are important differences too. One of the most significant is its location within its solar system. Proxima b orbits much closer to its star than Earth does to the Sun, just 0.05 astronomical units away, compared to Mercury's 0.39 astronomical units. Despite this closeness, Proxima b isn't overheated because its parent star, Proxima Centauri, is a faint red dwarf. The planet receives only about 60% of the energy that Earth gets from the Sun, placing it squarely within the habitable zone where conditions might allow for the presence of liquid water and possibly life. So far, astronomers have identified an astonishing 4,935 exoplanets scattered across the universe, with 65 more recently added to NASA's Exoplanet Archive as of March 21st. This brings the total count to over 5,000, marking a significant milestone in planetary discovery. Thanks to cutting-edge technology like the James Webb Space Telescope, JWST, which is 100 times more powerful than its predecessor, we are now more capable than ever of probing deep space and uncovering the secrets of distant worlds. Among the many planets identified, some stand out for their similarities to Earth. One such example is Kepler 1649c, currently considered the most Earth-like planet discovered and a prime candidate for supporting life. Out of all the planets found, scientists have pinpointed 55 that closely resemble Earth, though many of them remain understudied. As technology continues to evolve, especially with instruments like the JWST, our ability to explore and understand these distant worlds will only improve. One of the telescope's primary goals in its early missions is to find and examine planets beyond our solar system, with a focus on understanding how they form and whether they might host water or biological life. The telescope's infrared capabilities make it especially effective at observing the birth of stars and planets. Infrared light can penetrate dust clouds, detect heat signatures from young celestial bodies, and reveal key molecules like water and organic compounds. Unlike visible light, mid-infrared wavelengths can pass through clouds that are up to 20 times denser, which is essential when studying newborn stars that are still hidden in their dense natal clouds. These observations are crucial for capturing the early stages of star and planet formation, where clouds of gas and dust gradually collapse to form new systems. As young stars heat up over time and giant planets cool down, they emit more infrared radiation, making JWST the perfect tool for tracking these developments. Its MIRI instrument will also target hot molecular gases near young stars, which could signal the early formation of rocky planets capable of hosting life. In the coming years, the insights gained from the James Webb Space Telescope will likely transform our understanding of planetary systems and their potential to harbor life. It offers an unprecedented opportunity to link mature exoplanets to their birth conditions and draw parallels to the formation of our own solar system. Through these powerful tools and groundbreaking discoveries, we edge closer to answering one of the most profound questions humanity has ever asked. Are we alone in the universe?